A few days back, I had released a video with a very simple proof of Pythagorean theorem, which you can reach with the help of this link over here. In this video, I'd like to give some reasons about how that is going to be possible. Now, for doing that, same as previous case, let me take the hypotenuse and place the midpoint of that hypotenuse exactly at the center of this square. Give it the same color for convenience. The next thing we need to do is to take one of the other sides, one of the perpendicular sides. Again, its midpoint has to be moved to the center of the bigger square. Again, this length also is equal to this length. These two lengths are of no need to worry. The next thing for us to do is, now I'm cutting them apart into different parts. Once that is done, these parts can be placed one by one like this. Now instead of taking these parts, let me cut them into a total of 8 parts like this. When I do that, and again get the different parts cut, when I cut different parts, now you see this length overall was equal to the length A, and hence its midpoint was moved to the center of this square. So these two lengths, this length and this length, have to be equal, and when I move it here, this length is half of this total length, and so it is with this triangle. So these two lengths are going to exactly meet at the center point. So it is with this as well as this. Okay, so now we have 4 triangles placed into it. There are these 4 triangles remaining. Now let us try to analyze these triangles. So for analyzing that, let me take this length and another length equal to the length B placed after this, and lastly let me take another length over here. So this middle length is equal to the length B. So let me take this length over here and try to analyze it. Now this length over here is exactly equal to the length B, which we had taken from the top as it is, and about these two lengths, they are both equal since we had placed the diameter at the center, and hence it will give both sides the same distance, and that distance was equal to this length, which is equal to C minus B divided equally on both the sides. So that length is going to be equal to this much. So let me just make that color this much, this, fine. So next let us take the same lengths and let us try to analyze them a little differently. So what I'll do is, instead of having to take these two lengths over here, I'll just take a single length. This is a single length which is equal to the sum of these two. So when I add those two lengths, B plus C minus B by 2, I'll get a length of C plus B by 2. The same can also be obtained by subtracting from C a length of C minus B by 2. Again, what we get is this length, which is equal to this line over here. Whereas, and the upper part is again equal to the same length. Now, these two lengths have a very great role to play over here. So the role they play is in these triangles. Let me take it on the other side. So in this triangle, this height is exactly equal to this length, C plus B by 2, and this length over here is equal to C minus B by 2. So let us apply all these same conventions at all these triangles. The next thing we have to do is to move these triangles one by one over to these points. Now the hypotenuse of these triangles are going to be exactly equal to the hypotenuse of these triangles. Since we had them both at the same point over here, they had this hypotenuse common. So these lengths are going to be exactly same, and their inclination also is going to be same. And let us have a look at the angle over here. This angle over here plus this angle here will be exactly 90 degrees since it's a right angle triangle. So this angle left over here is going to be exactly equal to this angle. So when we take in the next triangle, it's going to exactly fit in over here with no gap left in between. So, and the same is going to be happening with all these triangles. So they're going to fit in exactly at this point, like this over here. Now let us try to subtract from this total height, from the total height of this triangle, this small height. So this is the base of the same triangle, you can see here. So we'd have to subtract from this length, the length of this, which will give us, when we subtract from this length a length of this one, we will get a length of B. So same B which we have over here. Talking about the angles over here, since this triangle is a right angle triangle and this line and this line over here are having no gap in between, so this angle naturally has got to be 90 degrees. So that means when we fix up these triangles in the middle, it's going to exactly leave a place for a square of length equal to B, which is this one. So that proves our Pythagoras theorem. Before ending up, let's have a look at the effect of variation of the lengths of the triangle. So this is another of the example wherein these two sides are of exactly the same length. So when that happens, under that condition, these triangles what we had formed over around in this triangle, they will completely vanish, and this square is exactly going to fit in over here, and this square divided, all these triangles are going to fit in at the sides. You can use this method to impress your friends or your teachers or those who feel themselves to be a lot more intelligent. Now you see there are many methods around in the world which prove this theorem with the help of a lot many equations and all those things. But geometrically proving it, well, that's going to be something different, right? You can start with a point and tell the person you're demonstrating it to tell you to stop when he thinks the length is of the correct order. So don't mind, you can take any length, he can tell you to stop at any length, there is no problem, since we have the proof for all the different conditions. Again, do the same for the next side. So proceed till your friend tells you to stop. Let's say it tells you to stop over here. Join these two endpoints to make a triangle complete. The next thing you have to do is you have to take these squares. You have to build squares. So now once you have built the squares, we are set to move. The next thing you need to do is a very simple math, which is this: C minus B by 2. C is the bigger length, B is the smaller length. So what you have to do is take this length over here, move it to this point, and whatever is left over here, that length is C minus B. So what we need is half of this length. So what I need is half of this length. So this length has to be moved over to this point as well as to this point. Now these endpoints when joined are going to provide us with a parallelogram over here. We are going to naturally get a length which is parallel to this and also of same length, since these two lines are parallel. Now the same thing has to be repeated in the rotated manner. So I'll just rotate it by an angle of 90 degrees to get this. Now once you have this you need to cut the paper along these lines. The next thing left is to move this one by one over onto this triangle, this square, and then very easily move this other square left onto the space which is left in the middle. So that is the demonstration for Pythagoras theorem.